Hey guys, continuing on with matrix operations, we're going to look at scalar products. And really the first one to be able to look at is just changing or inverting the signs within the matrices. The opposite, what we call the additive inverse, is obtained by replacing each entry with its opposite. So what was the original matrix A? If I use the additive inverse, I turn that into a negative A, and subsequently all the signs inside all my elements or entries change. They flip signs. So it becomes a negative A to positive 2, negative 1/2, and so forth. That is the same as multiplying through by negative 1, which leads us to scalar product. The scalar product of a number, and we call it K, and a matrix A, is the matrix denoted by Ka, meaning that I'm going to multiply K by the matrix A, which means that I'm multiplying it by all of the entries. So, scaling up, K will be greater than 0. It means I'm increasing the entry values. Scaling down, K will be between 0 and 1. It's a fraction. Given my matrix A, these are my entries. I'm going to say 2A. It simply means I multiply everything by 2 inside of there to get my new matrix. 1/2 A, I multiply everything by 1/2 or divide by 2. That is the scalar product. The other thing that I would like to show you, this isn't something to really go over, but so that way you're aware, is the different properties of matrix addition and scalar multiplication. And it's dealing with the associative properties and the commutative property and distribution. Zero matrix, that's something to just be familiar with. It's whenever all of your elements are 0. And for what we're getting ready to do, I would like to point out that multiplication of matrices is usually not commutative. In general, whenever I just talk about basic multiplication, if I say 2 times 3 and 3 times 2, well, it's commutative. Multiplication is commutative. But for matrices, it is not. So it's important to be aware of that. And otherwise, guys, that is scalar multiplication. Watch your publisher's videos, critically think and structure your homework, and good luck on the homework problems.